Hello, everyone. Welcome to the LeetCode problem of the day for Wednesday, April 24th. The problem today is nth Tribonacci number. And this is an interesting problem. It's an easy one. It says the Tribonacci sequence T sub n is defined as follows. T sub 0 is equal to 0, T sub 1 is equal to 1, T sub 2 is equal to 1, and T sub n plus 3, so this is going to be a recursive definition of the sequence, is equal to T sub n plus T sub n plus 1 plus T sub n plus 2 for n greater than or equal to 0. Given n, return the value of T sub n. So this is an interesting problem because we are given a recursive definition of a sequence that is similar to the classic Fibonacci sequence, right? So the Fibonacci sequence starts with the numbers 1 and 1 and then says for every following number in the sequence, you add the previous two digits together, the previous two numbers in the sequence together, rather. So to get the third element of the sequence, you would do 1 plus 1, which would be 2. Then, to get the next element, you do 1 plus 2 equals 3, 2 plus 3, 5, and so on and so forth. What this is saying is given 0, 1, and 1 as a start, add the previous three numbers together, and that becomes your next answer, right? So it would be 2, then 1 plus 1 plus 2 is 4, and then 1 plus 2 plus 4 is 7, and so on and so forth. So we can use dynamic programming to solve this problem. There are other solutions. You could do this recursively, or you could write a for loop to do it. We're still going to use a for loop, but we're going to use dynamic programming to practice our dynamic programming skills and also offer up a neat solution to this problem. So to start, we need to handle our base cases, right? So if n equals 0, turn to 0. If n equals 1 or n equals 2, return 1. And basically, this is just because our recursive definition of the sequence won't work for any values where we are in the first three values of our sequence, right? So we need at least three previous values to calculate the current value. So anything less than n equals 3, we will not be able to calculate the answer to our sequence. And we'll have to go with our base cases, which were defined here. So we handle that up here. Next is we're going to define our dynamic programming array. And I was going to write it using DP, but instead, to keep consistent with the sequence that they give us here, the sequence definition that they give us here, I'm going to call our sequence T, and I'm going to say T is equal to, we'll initialize an array of zeros, or a list of zeros, of size n plus 1, right? Because if our n is 2, we need 3 elements because we start at 0. So it would be t of 0, t of 1, t of 2. And so we therefore need n plus 1 elements in our list because we need everything from 1 to that number plus 0. Next, we're going to set our base case values again. We're going to say t0 is equal to 0. Then we're going to say t1 is equal to 1, and t2 is equal to 1. Now, we're going to loop through our values up until n, right? Because it's a recursive definition, so we need to calculate everything up to n. We're going to say for I in range, and I'm going to say n minus 2, and that will make sense in just 1 second, because we're now going to say t of I plus 3 is equal to t of I plus ti plus 1 plus ti plus 2, and that directly mirrors the recursive definition provided above in our problem statement. So n minus 2, right, if you recall, ranges stop 1 before the n, so we'll stop at n minus 1, and then this will be the value n minus 1 plus 3, which is n plus 2, right? And so if you recall, we want to determine this n plus 2 value because, let me correct myself real quick there. Rather, we're stopping 1 before, so we're not stopping at n minus 1, we're stopping at n minus 3. So then our final value would be n minus 3, or t of n minus 3 plus 3, right? So t n minus 3 plus 3 is going to cancel out the t of n. So we're going to go until we find our t of n value, which will be our answer because that will be the value of t of n. So we can say that, and then we can just say at the end, return t of n. And we test our solution. We see we get an error. Can only concatenate list, not int to list. So we see, okay, we need to put this in parentheses because it is multiplying the list by n and then adding 1 to a list. And obviously you can't add an integer to a list. You can append it, but you can't do addition between a list and an integer. It just doesn't make sense. So the interpreter is giving us an error here. We'll run it again. And we get a pass. So let's submit. And you can see we pass all test cases. Hope that was helpful, and I hope you enjoyed.